I am Penny. In this video, we are going to see about major process synchronization problem, that is the producer-consumer problem. So let's move to the introduction. Producer-consumer problem is a classical synchronization problem. It is also called as bounded buffer problem. It is actually described by Dijkstra in the year 1965. Let's go to the conditions. Certain conditions must be met by the producer and the consumer process to have a consistent data synchronization. The first one is that the producer process must not produce an item if the shared buffer is full. The second one is that the consumer process must not consume an item if the shared buffer is empty. The third one is that mutual exclusion, that is either the producer process or the consumer process must access the shared buffer at a particular point of time. Like both of them cannot access it simultaneously. So that's what they have given. That is, at a certain instance, only one process should be able to access the shared buffer and make changes to it. Then here comes the pictorial representation of the producer-consumer problem. Here is a producer and here is a consumer. This is a shared buffer. Initially, the producer produces the items and saves it into the shared buffer. The consumer consumes it from this end, and the producer produces and supplies it into the shared buffer from the other end. As the consumer consumes the items, the items in the shared buffer gets reduced. As the producer produces and inserts in the shared buffer, the number of items get increased. So the solution to this producer consumer problem can be given by using the help of semaphore variables. There are three semaphore variables that is used: full, empty, and mutex. The semaphore full variable tracks the space that is filled by the producer process. Initially, it is given the value 0, as the buffer will be there will be no items produced by the producer. The empty indicates the empty spaces in the shared buffer. Initially, it is set to the buffer size at it is full as the buffer is empty, and the mutex is to indicate that only one process can read or write the shared buffer at a particular point of time. So it is set to 1. And so we'll now move on to the algorithm part. And so here we can see that the semaphore mutex variable is set to 1, the semaphore empty is set to n, which is the space of the size of the shared buffer, and the full is set to 0. And this is the algorithm part of the producer, and this is the algorithm part of the consumer. Initially, in the producer section, if the producer needs to access this part, initially there are two functions, the semaphores main functions, that are wait and signal. The wait tells the other process to wait, and the signal signals to resume its process. Like initially in the producer section, the wait process, when it is called, the wait process decrements the value of the variable empty, and the signal process increments the value of the variable which is provided as an input. So here, as you see, weight of input, when a producer produces this an item, the value of the empty variable is decremented by 1, and the when the weight of mutex is called, it decrements the value of mutex. And so in the midway part, if the consumer tries to process consume the resource from the shared buffer, as you see, when it calls weight of empty, it will be reduced, but when it calls weight of mutex, there is a condition for wait buffer, like wait function, that it won't allow the value of the variables must be greater than 0. So here, as the producer has already called the wait function, the value of mutex is decremented by 1, that is, it is set to 0. So it can't access the shared buffer. So it must wait till the producer calls the signal of mutex, so that the mutex is again incremented to 1. So that way mutual exclusion is achieved in this process. So that's it. Thank you.